Welcome everybody to the Frontend Lighting Talks. We're live today again with lovely people already in the chat. I see some good evenings as well, some familiar faces during the last meetups. So welcome. Different time today. Well, we will have some fun actually with the Frontend Architecture session. The Frontend Architecture session is a very famous one, I would say. This is the second one we're doing and also quite regularly visited. For today, you can put your questions in the chat. We want to have an informal and inspirational vibe, so feel free to just chat with your fellow developers. We're all developers here, so technical questions are allowed, business questions not, unless there's, of course, some relevance to it. I'm your host today, but we have a full team, of course, with lovely presenters. I have Marcel here next to me, and after Marcel, Joris will be presenting. He's also here, and I'm the host. And for the meetup group, where you all in, hopefully, or you are internal within Society, that is also possible. You can follow us. We post regular links for YouTube as well. So this session will be recorded for you, and you can watch it back if something technical or interesting is there for you. But also upcoming meetups. The next one will be probably around November. So be ready for that one as well. We already have 1,700 members, and we like to do more with you. So if you want to present sometime as well, or have any feedback for us, well, feel free to connect with me or one of the other meetup organizers. Well, what we do, we're at Society, but we don't want the recruitment talk because we are developers loving to share knowledge. But we do a lot of things. So from cloud to front end, which we all love. In that case, we also security and much more. But we're here together with the front-enders, of course, from different clients, different perspectives. And this is a small group. We like to do it ourselves. The front-end core team of Society organizes this. So help us with searching for speakers. And if you want to present, you can also do it. This is one meetup, but we also have another one. And since you're all here, we are kind of a semi-partnership for the Netherlands-based people. The 10th of October, Frontmania is there. With this front-end community code, you will have 20%, 25% off for your ticket, which will be quite an amount, I would say. It's a full day of front-end inspiration in person, so not an online meeting. And later this session, we will give away 5 free tickets for the quiz question. But for today, because what you're all here for are the presentations, of course. First, we're going to start with Marcel with applying the C4 model on Frontends. Afterwards, we're going to unbox Frontend Architecture with Joris, and then we'll do the giveaway. If there are no other questions in the chat, we can start with Marcel in that case. So let's give it a go. Marcel, you can share your screen and give him a round of applause via the emoticons, please. Nice.
Thank you. Let's see. Welcome, everybody. Welcome to my, the first session of today, where I'll be talking about the C4 model and how we can use it and apply it to front-end architecture. First off, I'm Marcel Schutte, lead solution architect at Society. I'm doing a lot of things with architecture, including front-end architecture, but I usually focus on the entire picture, but still front-end is part of that. So, and today I'm going to show how you can use the C4 model to actually get a lot of information about your front-end in your architecture. Well, let's start off. C4 method is a well, I'm just going to read it. It's a simple, lightweight approach to describing and visualizing your software architecture using layered levels of abstraction. Easy to learn for everyone and perfect for both technical and non-technical audiences. What it really means, we're going to see later on. We're going to look at every level of the C4 model. And the front-end part is at the back, but we first have to go through the theory before we get into the front-end details. A little bit of what we'll be talking about today, or what I will be talking about today. A little introduction to the C4 model. We're going to see some models and some approaches to how you can show your architecture. And And at the end, we're going to see how we can use it on the front end. All right. Well, quick introduction about the C4 model. Because it's a lightweight framework, it's easy to understand. It makes clear communication possible. And by doing this, you get better designs. And because it's very lightweight, you can also discuss your architecture with all of the everybody in your company that's a stakeholder to your project. Because you have different levels of abstraction, you get the possibility to actually talk to the business, but also to the developers with the same model, just using different diagrams that you generate based on that model. Well, a little more introduction. C4 stands for Context, Container, Component, and Code. It's 4 layers. The top layer is the context. It just gives an all-round context about where in the landscape your application is situated. So you know with what other systems your own system is communicating. And that's the top level. It's also further down you get more and more details with more and more information, and it gets more technical the further you get down. C4. Let's have a look at the 4 key levels. As I said, the context is the highest overview of your application. It just gives the context in the landscape. The next level is the container. It shows what kind of components are in your container. Application services, databases, also front-end applications, of course. That's why we're here. Anyway, so one level down is the 3rd level, is the component level. It's a very detailed view of the internal structure within each container. You have a look at every container you've got, the front end, the back end, the API, the database, well, every container. And the code is an in-depth look at the source code and implementation details, which is most of the time, this level is done with UML diagrams. We won't be diving into UML today, because why would we? Please. For just in your team, UML is fine, but as soon as you start using it in a broader context, it loses a lot of its meaning. Today, for the front-end architecture, at the end, we're going to really look into component and code. I've got some nice adjustments to the C4 model, which make it better for front-end architecture. So no UML today.
Yay.
Well, let's have a look at the C4 model. Before we start diagramming, the C4 model has 4 abstractions: person, software system, containers, and components. Person, anybody that interacts with your system. It can be the user well, back home, but it can also be an internal colleague who's working on your system. The software systems, that's the high-level system. That's I have an example later on of a banking system, and the complete banking system is your system. The container is once again your entire system with the components in them, and the last abstraction are the components. They handle specific functionality, like once again databases, APIs, front ends, stuff like that. Well, because the framework is very lightweight, you don't get a whole lot of different arrows, different boxes. It's really, well, lightweight.
User-friendly, yeah.
User-friendly, yeah. Because you get a couple of icons that make up everything in your diagram, and you just make sure you make a good model of it. You can just actually, you can generate the diagrams with this. As you can see here, there's just the container, the database, the other container, mobile app, and even in this one, this is already more than the basic set. The basic set is just the container, the database, the person, and the external system, and the relationships, of course. But this is just a little bit extra for the front end icons. Well, let's have a look at a big model. This is the very zoomed out. This is these are the layers of abstraction. You start at the top with the level 1, which is the context. It shows the top system with just the surrounding external systems. And after, you can just zoom in. Every step is an extra zoom level, giving more details, giving more information about your system. We'll be running through those in a minute. But because of this, you give more details. Every step also makes it more technical, which at the end, well, in this case, it ends in UML. Once again, I'm not going to do that today. But you are going to use this in your development team. Then the UML part will come in handy when you're creating code, when you're talking to your fellow developers. But as soon as there's more non-technical people as a stakeholder, and you need to show them what you want to do with your architecture, you go up a level and give more context and less details. Well, let's have a little look at the first level. It's the context diagram. In this case, it's an internet banking system with, you can see the standard abstractions again. The customer, which well, in this case, it's an internet banking system, just making it possible to check your balance, pay via your telephone or whatever. But at this level, it's just a banking system that has a connection with a mainframe and an email system. That's it. To most high level in the business, this is enough. They just need to know, all right, we have our system. It connects to a mainframe and it has an email system. That's enough. But as soon as you start developing your system, you have to go deeper. You have to go to the next level, which is the container diagram. Already gives a lot more information. The dotted line, that's actually, those are the borders of your system with all the components in them. And those components can also be, once again, be made up of different other components. One single thing that I'd like to point out is put the legend. I think it's a legend. Put the legend next to your diagram. And this makes it possible for anybody who sees the diagram to actually understand the diagram, because it's a very small set of icons. The understanding of these diagrams is pretty easy. You can just take the legend with it and have a view of your diagram. All right. Once again, also the two external systems are still in this diagram, but outside the dotted line because it's not part of your system. We saw that in the context diagram, and now it's also visible in the container diagram. What if, let's say, I'm going to do a little bit backend. After that, we're going to go to the front end. Next one is the component diagram of the API application. Once again, the two components that are using it, the single page application and the mobile app, are using the API application, which is the new border. The dotted line is now all around the parts that are in our API application. And you get to see more and more components that are actually in this system. And you can also get the other systems that are used, the database, the email system, mainframe, and you give every component, you give it a short description with the different relationships between those boxes, and you put text on those arrows because that makes it easier to understand why part of the application is using the other part. You get the opportunity to put a lot of text there, but keep it clean, keep it direct and well, simple actually. All right. Here's where the front end
the lovely bits, the front end.
Front end. Why apply the C4 model? In my experience, this isn't done quite enough. The C4 model, you see it used a lot, but it straight goes to the API application, just like you saw in the previous one. But it has definitely got its worth in using it in your front-end architecture. It's still going to create a great view of your architecture, and you also need to know what happens in the front end. You can't just say, well, something happens over there, and well, see what happens and what kind of connection is there. And by actually taking it up in your software architecture, in your complete diagramming and in your model, it helps with the collaboration between the front end and the back end team. And by actually putting it in the same model, it really helps with the communication. It's you are creating actually one truth of your application, and not just loose diagrams everywhere. You create a model, and from that you can continue working on the same application from front end and back end.
There's a good comment in the chat about it as well, like the C4 model, the 4 different steps inside the model, as Ankit mentions, can be divided like high-level design, C1, C2 basically, and then you go a little bit deeper, so low-level design, C3, C4 in that case. That really helps communication with the business.
True, because well, we're actually now going into the actually front-end architecture. At the first 2 steps, the context and the container diagram, there's very little context about the technologies used. Now that we're going to the component layer, you're actually going to see what kind of techniques you're going to use. So these are the levels that are actually really useful to use in your front-end architecture. I've got well, two changes I usually make when I'm creating a component diagram when I'm doing it for front end. I stop calling it a component diagram, because in front end, a component is is a name that is already tied to a very distinctive part of front end, a module, component. So that's why I rename it to the module diagram, just to give it well, to make sure it's different than components.
They don't want to mix definitions, indeed.
And from this moment on, I let the UI, the user interface, define the breakdown. I'm going to see what kind of modules are in there, login, settings, in the case of banking, paying or checking your balance, stuff like that. Let's see, I have a nice little picture of this. It's not a banking system. It's actually for a real estate application. You see, they divided the modules based on the functionality of the module. In this case, a dashboard, a settings, a login. And it also still shows the API application, the external systems, but you get a way more clear overview of the relationships between the modules and the other parts of your system. Well, as you can see here, You've got a dashboard that actually talks to the API application, settings, and the login just goes through a third-party authorization provider. This makes it very clear of what you want to do with your system and with your front-end pages. It's also something that's once you do it's not always one screen per module, but it keeps the functionality combined and together, and in this way you can put it in a module diagram.
And the definition of those modules, you think about it with your team, I guess, right? Or what should be a module within your team so it can be different.
And what you also see a lot of the times is that it's also functionality that is combined within your in your workspace. You combine all those things used for login or all those things used for settings, just so that not everything gets tangled up. All right. This was my first adjustment to the C4 model when I'm doing front end. I stopped calling it component diagram. I made it a modular diagram, and the UI guides the breakdown. Now let's have a look at the fourth level, because that's where, well, usually UML, but in the case of front end, I'd like to introduce something else. No, this is what I talked about just now. Let's skip to the fourth. This is the fourth layer. I create a diagram of, in this case, I've used the page and made boundaries with the line, but I like to start out with the module. A module is the base part of this diagram, and you add to this all the screens that are used for this diagram, used for this module. It has multiple tabs in this case, but you can put those in the same diagram just to get a view of what is possible in this on this page. I like to use the features for something that is a collection of multiple components. So in this case, a feature are the guest accounts, because there are a couple of components in there that are just combined to make something a bit more than just one component. And you also add the different components to this as well, with the, in this case, a table with the guest accounts. I think this is a really nice way of showing what you are doing with your pages and different functionality within those pages. But this is what I want like to show you with the C4 model and the things I've added in my own way of working with the architecture for frontend. Well, let's have a quick look at the key takeaways of what I've talked about today. The C4 model breaks down system into context, container, component, and code. Those are the four key layers. Context, highest level, the least details, and the code views are the most technical, most detailed, lowest level. And by combining these diagrams in one architecture, you have the opportunity to talk to technical people as well as non-technical, and to make sure they understand what you're trying to do with the system and in what way you can, what you're trying to achieve with the system. Well, the C4 model offers a clear structure for modeling complex systems. Yeah, because of the layering, you get different amount of details at the different levels, which makes it easier to understand what your system is doing. And by actually using it for, well, front end, as back end, as, well, anything else, it is possible for those teams to collaborate on the solution together to make it to make it a success. As I said, it's applicable to both front-end and back-end architectures for just the complete and holistic view of your entire system. Thank you for your attention. If you want to contact me with questions, remarks, anything else, well, those are the things where you can contact me. Slides are over there at my GitHub account. And thank you.
Thank you, Marcel. Well done. Some applause in the chat. There's also some questions there. I like how you see the difference between business and the technical perspective and bringing it all together inside this model. I think it really helps as understanding each other. In the end, you're creating one product for the user. And it really helps. Nice. There are indeed a few questions. I will read one of them. First from Gardav. Is the C4 model similar to the Sagman framework, where we talk about differences of the domain of solutions? There's a whole chat in there, but do you know the Sagman framework?
No,
okay.
I do not. But,
maybe it's good.
I'll have a look.
Yeah.
I haven't heard of it before, but I can check it out, and I'll get back to you to your question if it's actually comparable to each other.
Nice. There is already a comment inside the chat as well. That's why we also ask everybody to put their questions in the chat, because other people can respond, and that's really nice. From Joris, he's saying, well, not really the Sagman framework. The C4 model is a layered model of different abstractions, where the Sagman framework provides different perspectives. That's already a nice beginning indeed. So thank you, Joris, who will be presenting in a few minutes. It's good to have the discussion ongoing. There's another question. How do we convince the developers that architects just don't draw boxes and arrows, as many would say the ivory tower, I would also assume. And can we integrate the C4 model to the code so we know if we deviate from the architects in that sense?
Yes, there is a possibility to do this. How you're going to convince developers to do something, I do not know. But it's the most important part in this way is make it as easy as possible to not only read and follow these architectures, but also to adjust them. That's why for the C4 model, there's also a DSL available, which you can just which makes it just plain text, and which you can actually put in your source control, so you can actually see changes you are making to your architecture. Those are all it's called Structurizer. It's a tool you can use on the web, but you can also run it locally or in a Docker container or well, whatever. And you can just create a plain text file with your system defined, and that also makes it easier for collaboration and changes in your architecture. But yeah, and it's an easy way to actually document your system. I really recommend using diagrams and a model of your application, and not a long. Well, everybody knows the Confluence spaces with very much text and very little updates, so this gets old real fast. So, and this creates a very nice way of actually keeping it up to date, because it won't be as much trouble as rewriting 20 pages of text. And that should really speak to developers.
Maintainability, yeah.
Things of use, because you don't want to do all the tedious work of updating text. And no, it's just one model of your system, plain text. It's maybe 2 A4s, something like that. Depends on your system, of course. But that makes it really easy to actually maintain. So I hope that helps your developers.
And can you name the tool once more, please?
It's a Structurizer. I'll put it in the chat later on. Nice. As soon as I step away from
it. As soon as you have the time, that's fine. Good question. Another one, I think that's one of the last questions. At what stage of the project should you implement such a model? Are there benefits to applying it at a later stage of the project?
I think you start out with the context and the the container diagram is something you can easily do at the start. It's really up to, you're not going to do a whole lot of designing up front. You're going to do, well, just enough design up front. So you start with the context and the container and move on from there. And you just, every sprint, you take some of the things that are being created into your architecture. And so start out at the beginning and update and update and update. Every sprint you're going further with your application. That's what I would do.
Nice, thank you. I personally also have one last question. That's the benefit of being a host, putting questions in there. Looking at the C4 model, I think inside the chat there are different levels of expertise. So from junior to architect. Do you actually need the architect title to start with it? Or can you just start with it from the beginning as a junior?
Yeah, you can. Reading is always possible. Also, as a junior, you also create features in your application. So you probably will be working more on your lower level, well, 3 and 4, the component and the code level. But as you get more senior, you'll notice you also get
the bigger scope.
The bigger scope. You get discussed all those things with the, well, maybe a designated architect. But you also see teams that are completely with the complete team responsible for the architecture. Yep. That also means the junior developers, and not only the one with the architect on his forehead. So.
Yeah, exactly. And I think that's one of the real cool benefits of this model as well. I think in general, if you can involve multiple people, you get multiple perspectives. Everybody can grow there. Thank you, Marcel. Once again, thanks for the questions. We will now continue with a speaker switch, so bear with us for a few seconds. And then Joris will start presenting. I think we can start. Give a big applause for Joris in that case. Let's go, Joris.
Yes. So I'm going to tell you a little bit about unboxing front-end architecture. I need to focus my window, otherwise I can't switch pages. Oh, this is me, Joris. I'm a paraglider, but also a technical solution architect focusing solely on front-end and front-end applications. And before that, I used to work for a very long time as a front-end developer, I think 14 years or something like that. But now more focused on the architectural side of it. And something I noticed is most of the times when you ask about the front-end architecture, you get a box. It's quite black, it's quite dark, and you don't really know what's inside. And that means that it's a system that can be viewed in terms of its input, its output, but you don't really know what's inside. We don't really understand our front end from an architectural standpoint. A lot of times we know exactly what's going on around it. We know how our front end interacts with all these other systems, what APIs it uses, how its backend is secured, what authorization rules it's following. All these things are very clearly defined, but still the inside of that box is quite dark, quite black, and a lot of times it's not even being opened at the architectural level. A lot of times it's just being opened by developers. And well, let's open that box. Let's look inside and see what we see. And I think we all have experience with that. Some might not, but most might have experience with it. And a lot of times this is what we see. So we get quite a mess. Not on purpose, of course, but a lot of devs are working on it. People are trying to build their features, but architecture on front end is not really a focus point. So you get, I would call it incidental architecture, which is created by accident. So it's not designed, there's not real thought put into it. And in real applications, it just looks like this. If you create a dependency graph or something, if you get this entire spaghetti, can't really make sense of what you're looking at. And that is kind of what I want to talk about with you. And I want to give you some pointers, some ideas on how to clean up that box. So let's go together to some ideas. What can we do to our front-end architecture to clean up that box? Look inside, take a look inside. Don't be afraid of what you will see, but find ways to fix it, to improve it. So let's talk about the first idea, cross-cutting concepts. And I guess some people might know what it is, some might not. Cross-cutting concepts are pieces of your application that don't really are one component. They're not really one thing. They go throughout your application, so they have impact on your entire application. That's why we call them cross-cutting concepts. And of course, I added some examples. A loading pattern. You have throughout your applications, you have things that load. If you look at bigger applications and there's no real thought put in, you also can find, I don't know, depending on how big your application is, between 10 and 100 solutions for the same loading pattern. So if you move that to a single abstract location, your code base all of a sudden becomes more coherent, simpler, and you can also onboard people, tell them where to look, how to solve this problem. And with that, you free up time, you clean up your code, but you also get more stable results. So it's better effectively for everyone. Other example, error handling. How many times are we looking at code and we think, oh yeah, it can also go wrong, and then solve it at the moment? Well, we work at Frontend. We have two reasons that can go wrong. We have users and we have the web. The web
never the developer.
No. It's always somebody using the keyboard and mouse. So we need robust ways to solve that problem, to find ways to tell the user that something goes wrong, bring them to a page that went wrong. And here again, find a consistent way to solve this throughout the application, throughout the front end, instead of solving this on a component by component level or service by service level, depending on how your application is structured. Other great example, authentication. Authentication and authorization. These are things that you have in your entire application. Most applications have some form of authentication, have some form of authorization, and they're complex problems to solve, but if you spend the time to identify it first as something that is going to be solved for the entire application instead of for your small component or part, you can really abstract it away, find a robust solution, communicate that, take the time to document it, and then focus on the things you want to focus on, which is not authentication and authorization, at least not more than once. Logging, a lot of times forgotten, but similar to the other ones, very important, and you need a very precise and good way to do it. And then these are the examples that are almost true for all applications, but your application might have some other ones based on specific requirements you got, based on something that either the business wants or the goal of the application is, maybe a component library you need to work with. It might lead to something that is not tied to a single thing, and you can move it to a cross-cutting concept, pick it up as such, spend the time to do it in a proper way once, clean it up. So clean up your code there. Other thing we can do, and something that we notice a lot, we have this very nice component created. If we do that one little adjustment, that component can do two things. And we do another.
There's one question, by the way, about loading pattern. I think you can quickly answer it. But is the loading pattern framework specific? And I think you can say something about cross-cutting concepts in general.
No, cross-cutting concepts are not even front-end specific. So they're not front-end specific. They're not framework specific. There are multiple ways to solve it. But in your front-end, you need to think about how you want to handle the scenario where you're loading. Because, well, there's probably a front-end application that doesn't load, but almost all of them have some sort of interaction with an API. And for that, we need to identify some sort of loading. And the idea that you think about that, solve it in a solution that is robust, reusable, and you don't need to invent the wheel every time something is loading. Of course, it might be that the UI is changing. That's not necessarily what we need to solve. If the UI is different per scenario, perfectly fine, but then make sure that the rest is the same, and you only need to do that UI difference each time. If the UI is the same each time, like you have an entire pop-up, for instance, that shows a loader on top of the screen, make that pop-up once, make sure that's reusable, that you can import it, that you can implement it quickly. And this has nothing to do with any specific framework. You can do this in Angular, React, Vue, Nuxt, Next, whatever you're using. So these, and it's true for all these things. So look at what your requirements are. How can you move that away from a specific implementation to a generic implementation for something that is going to be happening throughout the application?
Yes, thank you.
Single purpose components. So what we see, we add things on top of our components. They grow, they grow, they grow. And each time there's pressure to add something new. Well, if you look at the spaghetti in the end, nobody understands anymore what that component is doing. So you don't be scared to, at some point, take some extra effort into making that component single purpose again. Make sure that it is a nice, usable component, or service, or directive if you're in Angular, or I don't know, something from your framework, doesn't matter. Make it simple and split it up. Go back to your original design, like you have one thing, and make sure that the interface is simple. So you need to reduce interface complexity. Make sure that your component is used in a logical way. This sounds very logical, of course, but in a lot of times you notice a component that does one thing. I don't know, it's called the icon component, but you can also put a text in there. And then it does everything that you need from your icon component because it is nicely in a round thing and I need that one letter. But it's not an icon anymore. So maybe you shouldn't use it because in the long term, it's going to bite you. If you use components in a way that it was not intended or the name does not imply that you're going to use it, make sure that you are clear on what your component is being used for and what your component does. Yeah, and then reduce or simplify dependencies. Sounds quite simple, but don't use 10 million things in a single component. Make sure that you can understand how the things work. If it uses a lot of dependencies, it might be worth splitting up just to make it clear what you're using that thing for. To make it into separate components that are nested, for instance, just for clarity. Go for a nice nested structure.
Yes, for coupling indeed. Clarity,
yeah.
coupling. Yeah.
Clarity and coupling, decoupling. And reduce state. And state, I don't necessarily mean state management. I mean a state in a component where a component knows what it is doing at what point. This is fine for a collapsed component. A collapsed component can know if it is collapsed or not. That's perfectly logical. Unless your parent needs to know, then the collapsed component should have it as a way to give it to the component and emit it from the component. And it should not be in the component anymore. But a lot of times you see some form of small state because it was easy to solve that simple problem. But now, all of a sudden, because you solved that simple problem, your component can't be reused. It's not clear what it is for, and it is tightly coupled to its parent or its children, where you want that coupling to be loose because it's a reusable component. So really be critical and make sure that your components have a nice single purpose and build them in that way. Another thing, it's a bit in line with what we just talked about, choose a consistent place for your logic. Logic should be placed, and specifically business logic, but a lot of the logic should be placed in a logical and consistent place so that other developers, but also you in the long term, or when something goes wrong, you can find where it is being executed. Don't spread your logic. So centralize it. Centralize your business logic into a single location. Can be multiple locations in a single folder to make your files shorter. You don't necessarily need to be in a single file, but make it then very clear what each purpose, the file of each purpose is. Is it a helper? Is it a util? Is it the service itself? Is it stateful? Is it stateless? Think about how to centralize your logic. Does it need to live in a component, or can it live outside of your component? And don't make your logic trickle throughout your application, because it makes it very difficult to solve problems. And again, when we look into some boxes, we actually see this quite a lot. And then the component logic that is there should only contain the code that it needs for its own responsibilities. So if we have that nice collapse component, it should have something about if it's collapsed. It shouldn't have something about if the padding on the left side of the title is there. That's part of the title component. So make sure that it has clear distinction in what kind of logic, what kind of decisions your component should make, and what kind of logic another component should make for a service or somewhere else. But make sure that it is not moved to the entire application. And then we're going to look at a very simple thing. So if you look at logic, we always have we in the end build a lot of times at least pages. And on the page, there is some knowledge, like what URL am I, maybe a title or something like that. But most of the times, a page doesn't necessarily need logic. For logic, I like to create functional components. So you have a component that has a certain business function. And the fact that it is a business function means it can have the business logic related to that function. You can centralize some business logic there. And depending on your requirements, that might be completely different, but this is a way that you can really simplify to think about it. And that means that the page doesn't really know other than which business functions it implements. And the business functions, they have state. So they are stateful, they know what they're doing. They might use a state management system, so they might hook into that, but that is then done from the functional component. And they just use simple building blocks, and they are then again, some components you just pass some data in and out, and they just display that data. But now, and that might have some logic, but not business logic. So the functional component is then the centralized place to do that. So that's the way I like to think about it, to really simplify the architecture of my application and think about how we can structure our application. So we just talked about things we can do to change the way we approach components a bit, or change the way an already built application, how we can approach an already built application. But now I'm starting something new. So I want to do it right the first time. So what should I do? Well, it sounds very simple. Don't over-design. And underneath that, the question, is it fit for purpose? But we see a lot of the times, we think a lot about how much problems we might have in the future. Some of them might be completely valid if you're 100% sure they will be in the future, which is next sprint. Some of them are more theoretical, and they result in a list of new problems you need to solve. So you go into this rabbit hole of solving a problem for another problem for another problem that doesn't even exist. And then again, the question is, when is it fit for purpose? When do you know what you need? And does it suit that goal? And if the answer to that question is it fit for purpose? You're kind of done designing. You don't need to add extra problems to it. So try to keep it simple. Challenge yourself also. Can I make it a simpler solution? Can I solve my problem in a simpler way so that it still is readable, it still is understandable? Some problems are complex and need complex solutions, but a lot of the problems really aren't. But we like to make them complex, but most times it's not really necessary.
Yeah, indeed. I think adding complexity is usually one of the culprits, basically, for developers as well.
Yeah, because we know about this nice solution, or we thought of this nice idea, and we're trying to fit that into an existing problem, but the problem doesn't really need that nice solution, but we still build it. So try to be critical of if you need that more complex solution, if you don't have that complex problem. It's it sounds really simple. It's actually quite hard to do, to not over design. So it's not an easy thing to do. But that also solves a large part of this problem. Think about, who are you working for? Who are you designing for? You're designing your code, you're designing your interfaces, you're building your application, you're building your logic. If you're in a team with only seniors and the company says for the next 50 years, we're only going to hire seniors and higher, sure, go ahead. But otherwise, if you're in any other company, you have to do something with, is a junior going to understand what I'm building? Is my naming scheme readable for anybody, for everybody? Everybody. I don't know, I noticed that sometimes I also build something and then half a year later I look at my code and I don't understand my own code. Which means I'm pretty sure a junior or a new employee would have no idea what's going on.
Everybody has the feeling sometimes. Yeah.
So keep that in mind. There are other people who are going to read your code. It's not just something that the computer is going to execute. It's also that other people are going to work in. And that means that your standard has to meet that goal. So the naming is very, very important. I keep saying it to everybody who wants to hear it. It's the hardest thing there is. Proper names for interfaces, functions, components is really, really difficult, but it's very important because the next guy who's going to work on it is going to understand what it does, knows how to adjust it based just on the name, and will probably do the right thing with it. Well, otherwise you get a lot of code duplication. And then again, build for change. Don't be afraid to think about what happens if that piece of code needs to go. Because we built something now and we got that requirement now, but a lot of the times requirement change. People think about new features, think about less features. There's a restructuring, new business goals need to be met. So that very nice thing you built 2 years ago now needs to go, or needs to be changed, needs to be whatever, something you need to do with it. So if your code is structured in a very clean way, your component is simple, your design is understandable, your naming is good, all these things that we just talked about are perfectly fine, well then the change is also going to be a lot simpler. So building with the idea that it's going to be scrapped means you also have to think about what happens if I scrap it. Is that understandable, or is there then, should we just start over? So that's something that you should really keep in mind while working on components. Yeah, and then invest time for foundations. This is a graph that gives you some idea of what happens. If you start delivering immediately, you'll probably deliver faster in the beginning. But at some point, and it depends on the complexity, the quality of the people, the requests, and whatever, you will slow down. And you will slow down significantly, and you will hit a ceiling. And at that point, you will only go down, and you will probably go down pretty fast because you just stuck. And you're only working your way into a deeper rabbit hole, trying to add things on top of something that is not working. Well, if you really invest time for the foundations, and with that also for the cross-cutting concepts that we talked about, you got a nice way to ramp up at a later stage. So in the beginning, you're just slower. But after a while, and it depends really on the scale of the project, how long a while is. If the project is going to be a very big project with a lot of teams that's going to work on that for 5 years, please make that while a year. If it's going to be a marketing campaign that's going to run for a month, well, of course you're not going to take a year. So it's really dependent on what you are doing, but take your time to get the basics right and think about how are we going to ramp up development in the long term. What are we going to need? What tools do we need? What IDs do we need solved before we can really ramp up on just adding functionality. So yeah, invest time for the foundations.
Talking about ramping up, we are running for time.
I'm
so,
gonna, yeah. That's all the question.
Yeah.
So,
please continue in an easy pace with no time.
Yeah. So what do we run into when we work on the front-end architecture? We see that a lot of ideas that we have on an architectural level, and especially on a higher architectural level, don't necessarily relate very well to what we have on the front end, especially because we have something called users, and that causes some additional challenges, and some additional challenges also to market better. So we need to keep that in mind, and that's not always something that's kept in mind when creating an architecture. Front end is sometimes not really defined. What is now the responsibility of the front end? Should it have business logic? Should it not have business logic? And if so, what type of business logic? Should it have validation? Should it not have validations? So we really need to think about these things, because otherwise we get this really nice clean backend and then a massive front end that not gonna work. And challenges move to the front. So we as a front enders are the last line before a user is there, which means database has a problem with it. The microservice architecture has a problem with it, but we still need to solve it. So we are going to solve it, but then it ends up being a messy front end again, where we have to ask 10 APIs to give one single value. This should not be on the front end, but it happens. So it's a challenge we have. So as a developer, we have a challenge to say stop. We should say stop sometimes. This is not something that we should solve. We should protect our own architecture, our own quality gates, and make sure that our application is just as clean as the rest of the application landscape. So, what are we good at? As front-enders, and I noticed this when talking to a lot of people, we're very good at thinking about unexpected scenarios. It has to do a lot with experience with users. And I really noticed that as well as an architect, that you're really good at thinking about scenarios that other people did not come up with, because you're always trained to think about these very weird edge cases, because we have users and users do whatever. And that's this. So we're used to
love them, we hate them.
We love them, we hate them, absolutely. And we also have a good starting point where we talk about business and IT. We're developers, we code, but on the other hand, we are also so close to the users that we also understand the business value of what we build. So, in summary, please help your architect sometimes with problems on the front end, because it's a bit of a forgotten space in a lot of areas. And a lot of architects are not really aware of the problems we have on front end. So that's why a lot of these things happen. And we should just get architects more involved in the front end, make sure that they understand the problems that happen on the front end, and in the end also can assist in improving the situation, while we as developers, so the front-end developers, should really take responsibility of the front-end architecture and try to improve. So, yeah.
Thank you, Joris. Well done, nice presentation. Give him some applause, please. Nice. I see there are a lot of comments, and I think one of the few things I really like is that you specifically mentioned front-end. What is your superpower, basically? That's nice to see. I think everybody can pick that up, and also looking into unboxing the front-end architecture.
Nice.
How can you start with unboxing the front-end architecture? Maybe use a T4 model, for instance.
Could be a way. You could do that. You could just generate a dependency graph. It depends on your application and your specific goal. Like if you want to unbox an entire application that is massive, you should start at a feature, for instance, and just look at that feature more critical. See what that feature is doing. If it adheres to the standards that you set, think about solutions. So it depends really on your problem. You can use the C4 model, you can use a dependency graph or an NX graph. It's also a dependency graph, actually. So there are ways, but the most important thing is look at it more holistically and see what you missed at, and then start by identifying, for instance, your cross-cutting concepts, and look did we think about this or didn't we think about it? And if you didn't, well, start thinking about it now.
Start doing
if you do that, if you start thinking about it, you're actually already unboxing it. But then from the perspective of a cross-cutting concept. So it is not necessary to write it down, create this entire graph. It's nice if you want to do it, please. But you could also start with things that you maybe saw and think, okay, I never thought about it. Start thinking about it, zoom into that part, try to improve it from that perspective, and you'll notice things falling into place and things around it becoming more visible.
Nice, thank you. I think other questions can be answered in the chat if you have still some answers. We will continue due to the time.
Sorry.
No problem. We like the session. I would like to thank everybody. And if there are questions, you know how to reach Marcel. You know how to reach Joris. In that case, you can reach me if you want to present in one of these sessions as well. That's always possible. Or feedback, because we are just mere developers and architects organizing this. We are no communication experts in that sense, but we love to do it and share knowledge, have some informal, inspirational fun. But without further ado, I think we still have something left for you. And that is a Fromania giveaway. We will give away 5 tickets. You need to contact me with the correct answer of the quiz question. Very exciting. It will be about what pattern is described. I will show it in a few seconds. You can contact me via LinkedIn or via the meetup messages. First come, first serve. I have 5 tickets to give away. It's Netherlands based in Utrecht. That's good to know. I will leave the screen open for a few more minutes, but this is the end of the session. I would like to thank you all for being here. Please spread the word, of course, about our meetup page. Give us a thumbs up, maybe leave a review. We like to improve and see you probably in November. Then is our next session. Thank you all, and have a nice day, and good luck with this riddle of a pattern.